Hi, good morning, everybody. I am Ioana Muntean. I represent RINA Consulting, which is an operational consultancy firm of RINA, a global Italian-based corporation that providing engineering solution, testing, inspection, and certification services. Moreover, we in RINA Consulting are focusing on project management, technical studies, engineering design across different sectors like energy, marine, or infrastructure. I am responsible in the Refresh project about the sustainability analysis for each process and product. And today I bring to you this topic, which is about the Refresh preliminary LCA results that we perform in the first part of the project. So life cycle assessment, it's a study that follows a methodology that follows internationally standardized procedure. So we follow ISO 40040 and 40044 in carrying out this analysis. And we follow the framework of the life cycle assessment, which is composed of 4 phases. So the goal and scope definition, the life cycle inventory, the impact assessment, and the interpretation. So I will spend a few words on explaining you how we set the basis in these phases for the analysis that we perform in Refresh project. So for the goal and the scope definition, we decided that we will have investigated the innovative Refresh recycling processes, and we will have comparative analysis between Refresh recycling processes and linear disposal practices. Then we wanted also to see the environmental benefits that arise from the use of secondary raw materials. And yeah, for this purpose, we also use available literature data, and we set the functional unit of this analysis as 1 ton of wind turbine blades to be recycled. Then moving forward in the life cycle inventory, which is the second phase of the LCA framework, we perform the inventory tables with data that we collected from our partners, from the technology provider partners that you already had the chance to see earlier in this workshop. And we base these inventory tables on high quality experimental data and measurements that was provided directly by our partners by the means of questionnaires. Yeah, for sure, these experimental measurements were obtained through on-site testing. And then we use EcoInvent databases to identify data sets, and we associate the data set to each flow that we collected and that we put together in the life cycle inventory. And then for the impact assessment phase, the third phase, we use GABI software, which is a software for life cycle calculation. So we move into the modeling phase, putting all the data and all the flows that we collected in the life cycle inventory table in this LCA software calculation. Then once this modeling phase is completed, we run results. And we use environmental footprint method to run and extract our results, which is the European Commission recommended method for evaluated environmental impact. But we wanted to look only in a few indicators. So we did not look into all 16 indicators because we were interested in looking on the global warming potential, which provide us the CO2 equivalent emission. We wanted to see resource consumption, and we also follow the waste production of these recycling processes, which is an important parameter, right? Because we are talking about recycling processes that we were analyzing in this study. Then finally, in the interpretation phase, which is the last phase of the LCA framework, we wanted to see the hotspot analysis. So in each recycling process, what are the hotspots? So in this way, we can provide a real closed loop of the flow or the process steps that were the most impactful to our technology providers. Then we had this comparison with the linear disposal, and then we elaborate the results to see also the preliminary environmental benefits. So this is a little bit just a diagram that shows the system boundaries that we applied in the life cycle assessment study for the refresh recycling value chain. You can see that in this diagram we can differentiate our partner at ATNOV, which is responsible for the cutting or pre-cutting phase, can apply cutting techniques, whether if we want to pursue a reuse pathway or whether if we want to pursue a recycling pathway. So you can see that in the red rectangle, we have the boundaries of our life cycle assessment, and we basically analyze three recycling value chain through the life cycle assessment methodology. The first one is the mechanical recycling, and the other two are thermal recycling. One with conventional pyrolysis, and the other one with microwave assisted pyrolysis. Then moving forward to some results. So in this image, you can see the results of the recycling versus the traditional disposal method. So basically, in the climate change impact category, all refresh recycling processes show lower environmental impact than landfilling or than incineration. I want to add an additional information. We compare mechanical recycling with landfilling and thermal recycling with incineration because there is somehow some similarity between this type of recycling processes and disposal methods. Recycling produces also secondary raw material that are capable of substituting virgin production. And indeed, this substitution leads to further avoided greenhouse gases emission because we avoid this type of emission because we avoid to produce other raw materials. So moving to my next slide, we can see here that all the recycling routes deliver large climate benefits because, as I said previously, we avoid virgin production. So if you want to look into the mechanical recycling, it's the process that basically delivers the largest net reduction in the order of almost 3 tons of CO2 equivalent. And end of waste material find application in the lightweight industry, replacing virgin epoxy resin. Then if you want to look in the thermal recycling processes, we can see that also this one deliver substantial net reduction, almost in the order of 1 ton of CO2 equivalent for the both type of pyrolysis, and this recycled material can substitute virgin glass fiber, glass and carbon fibers. This is my last slide. I wanted to say that this is just one of the role of RINA in Refresh project, because beyond of this, you see the first presentation of my colleague Daniel Grisenti, which is the coordinator, but RINA has also other activities in the project. But I think that the sustainability analysis is an important activity and role in a research and development project. And yeah, we performed, just to recap, we performed the life cycle assessment of the recycling processes and value chain based on experimental data, and we performed this study according to the ISO methodology. We are performing currently an end product sustainability assessment that includes LCA, LCC, and social LCA of a new wind turbine blade, which is manufactured with recycled glass fiber that is recycled by our partner Gencraft. So with the fiber recycling in Refresh project. And yeah, we are also performing life cycle costing and social life cycle assessment. And by the end of the project, which will be December 26th, we will have a final publication where we will present the consolidated sustainability results of Refresh project. And if you want to have a little bit more detail on these results that I presented in this presentation, there is a press release that you can see, you can find online on project website or on LinkedIn channel, and you can read it and find more details there. I finished my presentation. Thank you. If there are any questions, I will be happy to answer.